NASA scientists have said something publicly that, if you really hear it, should stop you in your tracks. They have said that within our lifetime, not in 100 years, not in 1,000 years, but within the lifetimes of people alive today, we are going to find evidence of life beyond Earth. Not maybe, not possibly. They believe it is coming, and the reason they believe it is not wishful thinking. It is the data, it is the missions, it is the instruments. It is the accumulation of evidence that has been building for decades and is now reaching a tipping point. Today, we're going to look at exactly why they believe that and what it means for all of us. We are living through a golden age of discovery. In the last 30 years, we have gone from knowing of 0 planets outside our solar system to cataloguing thousands of them. We have sent rovers to Mars that have found organic molecules and unexplained methane. We have discovered that the moons of Jupiter and Saturn harbor vast liquid water oceans beneath their icy surfaces. We have detected water vapor in the atmospheres of distant exoplanets. We have built a space telescope, the James Webb, that can analyze the chemical composition of a planet's atmosphere from 100 light-years away. We have found phosphine in the clouds of Venus that no known chemistry can explain. Each of these discoveries, taken alone, is remarkable. Taken together, they paint a picture of a universe that is far more hospitable to life than we imagined even a generation ago. And the pace of discovery is not slowing down. It is accelerating. In the next decade, several missions are going to dramatically advance our understanding. The Europa clipper, currently en route to Jupiter, will arrive at Europa in 2030 and begin the most detailed study of that ocean moon ever conducted. It will tell us whether Europa's ocean has the chemistry and energy sources needed to support life. The Dragonfly mission, scheduled to launch in 2028, will send a rotorcraft drone to Titan, Saturn's largest moon, to explore its surface and search for signs of prebiotic chemistry or even life. Titan is a world with a thick atmosphere, lakes of liquid methane, and complex organic chemistry, a natural laboratory for studying the chemistry that might precede life. NASA's Da Vinci probe will dive into Venus's atmosphere in 2029, sampling the clouds where phosphine has been detected. And the Mars Sample Return mission, if it proceeds, will bring Martian rocks to Earth for analysis with the most sensitive instruments ever applied to the question of life on another world. Any one of these missions could make the discovery. Any one of them could return data that changes everything. And that is not hyperbole. That is the considered judgment of the scientists who have spent their careers working on these questions. The convergence of multiple promising targets, multiple capable missions, and multiple powerful instruments creates a situation that is genuinely unprecedented in the history of the search for life. We have never been this close. We have never had this many shots at the answer simultaneously. But let's be honest about what finding life might actually look like. It is unlikely to be a dramatic moment of contact, a spacecraft landing on a world teeming with visible creatures, or a radio signal spelling out a message in prime numbers. It is more likely to be subtle. A chemical signature in a Martian rock that is consistent with biological activity. A pattern in the atmospheric data from an exoplanet that suggests the presence of biosignature gases. A microscopic structure in a sample from Enceladus's plumes that looks like a fossilized cell. These discoveries would be profound, but they would also be contested. Science does not work by dramatic announcements. It works by evidence, replication, and debate. The discovery of life beyond Earth would be the beginning of a long process of verification and understanding, not a single moment of revelation. And that process would be fascinating to watch. The scientific community would mobilize. Independent teams would attempt to replicate the findings. Alternative explanations would be proposed and tested. The debate would be intense, rigorous, and ultimately productive. Science at its best. And eventually, perhaps after years or decades of work, a consensus would emerge. And that consensus, if it confirmed life, would change everything. What would it mean, scientifically, to find even a single bacterium on Mars? It would mean that the origin of life is not a one-time accident. It would mean that wherever the conditions are right, life gets started. It would mean that the universe is, in a very real sense, alive. That biology is a cosmic phenomenon, not a terrestrial one. It would transform our understanding of evolution, of planetary science, of the history of our solar system. And it would immediately raise the question of whether Martian life and Earth life share a common origin, whether life spread between the planets on meteorites, or whether it arose independently on both worlds. If it arose independently, if life on Mars has a completely different biochemistry from life on Earth, that would be even more significant. It would mean that life is not just possible elsewhere, it is inevitable. That wherever the conditions allow, chemistry becomes biology. That the universe is not just hospitable to life, it is generative of it. The implications would cascade through every field of science and every domain of human thought. Every assumption we have ever made about our uniqueness would need to be revisited. There is also the human dimension of this moment that deserves acknowledgement. The scientists working on these missions are not just doing jobs, they are pursuing a question that has haunted humanity since the beginning of recorded history. They are the latest in a long line of people who looked up at the sky and refused to stop asking. And the tools they have built, the rovers, the telescopes, the spectrographs, the probes, represent the accumulated ingenuity of thousands of researchers across decades. When the discovery comes, it will belong to all of them, and in a very real sense, it will belong to all of us. We are standing at the edge of that discovery. The tools are built, the missions are launched or launching, the scientists are ready, and the universe, which has been keeping its secrets for 13.8 billion years, is finally beginning to yield them. We are the generation that gets to be here for this. That is an extraordinary privilege, and it comes with a responsibility to support the science, to stay curious, and to be ready for whatever the answer turns out to be. If you've been with this series from the beginning, thank you. And if you're just joining us, subscribe and go back to episode 1, because this journey is worth taking from the start. In our final episode, we're going to zoom all the way out to the very end of time and ask what the existence of life means for the long-term future of the universe. It is, I think, the most beautiful question of all. The final episode is next, and it's the one that ties everything together. Subscribe, keep watching, and let's finish this journey together. You've come this far. Don't stop now.